We're now ready to define one of the most common descriptors of a line, the so-called slope of the line. Here's how we define the slope of a line. The slope of a line is the ratio of the change in y to the change in x between any 2 points on the line. That's the description in words. In terms of variables, the slope, labeled m, can be calculated by taking the change in y over the change in x. Sometimes we shortcut this notation by, instead of writing y2 minus y1, writing this triangle symbol to mean change in. This triangle symbol is called delta. It's a Greek letter, and it means change in. So I would read this expression as delta y over delta x. Now here's the really exciting thing about the slope of a line. It doesn't matter what 2 points we pick. We get the same slope. Here's why. I'm going to draw a line. Let's say we've drawn this line, and we see that it passes through all of the points in blue. Now their coordinates, this one is x equals -1, this one is x equals 0, y equals -2, this one is x equals 1, y equals 0, this one is x equals 2, y equals 2, and this one is x equals 3, y equals 4. What does the slope look like? Well, let's say I want to calculate the slope using these 2 points. I'm going to call this point x1, y1, and I'm going to call this point x2, y2. So I'll have the slope is y2 minus y1, so that'll be 0 minus -2, over x2 minus x1, that'll be 1 minus 0. So that'll be 0 minus -2, that's 2, 1 minus 0 is 1. So the slope is just the number 2, or if I want it to look more like a ratio, 2 over 1. On the graph, what I see is, to get from x1, y1 to x2, y2, my change in x is positive 1, my change in y is positive 2. Alright, what if I picked different points? What if instead I picked these 2 points? Well, again I would calculate my slope. 4 minus 2 over 3 minus 2. Again, that's 2 over 1. Again, I go right 1, up 2. Why, though? Is that just a coincidence? Well, no. Thinking about what we said about similar triangles. Remember how we drew our axes so that they were at right angles to each other? That means that all of our grid lines are at right angles to each other. So in particular, we have square corners in the bottom here. If I draw this big triangle, the red triangle and the black triangle have two angles agree. Namely, the right angles agree, and this angle that they have in common agrees. So the red triangle and the black triangle are similar. The black triangle and the purple triangle have two angles agree, namely, the right angle again, and the angle at the top that they share. So they're similar, which means the red triangle and the purple triangle are also similar. And the slope is a ratio of corresponding sides. Right, it's the ratio of the side on the right to the side on the bottom. Because the slopes then are calculated as ratios of sides of triangles, and for the same line all the triangles are similar, the slope is going to be the same no matter what 2 points we pick, which means we should just pick whatever 2 points seem most convenient. Let's see one more example where we calculate the slope of a line. So here's a line. We're going to calculate the slope in two ways. We'll calculate the slope by looking at the distances in the diagram and by using the formula for slope. For either one of these methods, I need to pick 2 points, and I'm going to pick these 2 points as falling on nice grid lines. Looking at distances in the diagram, to get from this point to this point, I have to go to the right 3, and I have to go up 2. So my slope is going to be my change in y over my change in x, so 2/3. Using the formula, I have to read these points off first. I have 1, 2, and 4, 4. So my slope will be 4 minus 2 over 4 minus 1, the change in y's minus the change in x's, which again is 2/3.